Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. So how are all of you today? Okay, so today we're going to look into chapter 9 with a 9.1 Introduction to Random Variables, 9.2 Discrete Random Variables, and 9.3 Continuous Random Variable. Okay, so one of the key important in this topic, which is the word of discrete and continuous. So we look into the first lecture of this topic. Okay, we look into the introduction and also discrete random variables. So in this topic, we're going to make a definition of random variables, construct the probability distribution table, and also here find the cumulative distribution function. Okay, cumulative and its median, and also find probabilities from the table and also from cumulative distribution function. So, a random variable is a variable whose value is unknown of a function that is assigned values to each of an experiment outcome. Okay. So then, random variables can be discrete or continuous. First one here, a discrete. When we talk about discrete, meaning we talk about an object we call that can be countable, or we call variable that have countables or exact value. So number of cars, okay, number of houses. So let's say if I have 15.79 students in my class, okay, 15% of 15 students, reasonable, but what about 0.79 student? Okay, even though might be one of my students have no leg or arm, we still consider he is one person, not 0.79. So for a number of students, which should be, there is no decimal point here, and this is unacceptable. Okay, continuous random variable, variable that can have any values within a continuous range, the height of the person, the time taken to complete an examination, or volume of water inside the bottle. Okay, probability. So when we talk about probability, we have this in our mind here, where the probability of any value of any probability, which is value lies in between 0 until 1. With the least is 0, with the maximum is 1. Okay. If x is a discrete random variable which may take k different values, then we call the probability of x lies in between 0 until 1, and the summation of all the probabilities equal to 1. So please do remember these two, because this is our reference. We call in our next example and solution. The probability distribution can be represented in the form of table, function, and graph. Example 1. So two fair coins are tossed, then the possible outcomes are, okay, so just imagine that, okay, so this is one coin, okay, so there are two faces, okay, is whether the face up here shows up, we call the value of the coins, 1 cent, 5 cent, 10 cent, 50 cents, or might be $1, one ringgit, okay. And on the other side of these coins shows us, we call any statue, or maybe we call building, which shows the, we call that building that we have in our country. So just imagine that if we seeing this as a head, and on the other side is a tail. Okay, So the result of this, it might be both when we toss both together or we toss one by one, we get the result of both with the head, both on the table once we toss, and then we see that on the table both with that, showing the result of head and head, head with a tail, tail with a head, or both tail with a tail. Okay, so let's X represent the number of tail obtained, represent the number of tail obtained. X equal to 0, 1, 2. Meaning, this is the result where head we call tail is not the outcomes. When we toss, when we see with our own eyes here, okay, and we can see that both of head and head, so there is no tail appeared here. Might be one tail, 1 and 1, or might be both with a tail. Okay, so then, okay, so if we reverse to the previous page here, there are 4 results, whether both H or H with a tail or tail with a H, meaning that these 2 coins we consider as 2 different coins. Okay, so if this shows the head and this shows the tail, or might be this shows the tail and this shows the head. So H and T, T and H is a 2 different result. Okay, and then both with T. So when we have 4 different results, and every single result here we consider as 1 over 4. 1 over 4, 1 over 4, and 1 over 4. So then, both with the head is only 1 result, so we consider it's a 1 over 4. But for head and tail, for these 2 coins, 1 will show with the result of tail. 1 here, another 1 here. So 1 over 4 plus 1 over 4, because these 2 results is different, but then we consider as a 1 here. Okay, we consider is equal. Okay, so this one plus with this, and then this is another result. It's only 1 result with a tail and a tail. So now, when there's no tail result here, it is 1 over 4. For both of the coins, at least 1 shows the result of a tail, which is 1 over 4 plus 1 over 4. 2 over 4, or it is 1 over 2. Okay, and there's only 1 result, both with a head and both with a tail, is 1 over 4. Okay, so then for the function, it is probability of x equal to the xi here. Okay, 1 over 4 for x, 0 and 2, 1, which is result of 1 over 4, and then 1 over 2 when x equal to 1. Okay, and then using graph, okay, using the graph, sorry. Okay, x and the probability of x. Okay, so we got the result of 1 over 4, 1 over 2. Okay, so when x equal to 0, 1, and 2. Okay, so now when x equal to 0, then the probability is 1 over 4. When x equal to 1, then it is half. And then when x equal to 2 here, and probability is 1 over 4. a fair dice is rolled. Okay, a dice, which I think that is familiar to all of you when we play a snake and ladders. Okay, any games that need to come, we call move up, that we call the token, that okay, token from one box to another box until we reach the we call the final box. Then here, okay, using the snake and ladders, so we use the dice 1, okay, let's say 2, 4. Okay, for example, a fair dice is rolled. If x represents a number on the dice, show that x is a discrete random variable and find the probability of this. Okay, so now x is number on the dice and probability of x equal to, okay, every single is a fair dice, meaning there are 6 surfaces, and every surface shows that we call the dot of number 1 until 6. And when we toss fair dice is rolled, we will get one result. Okay, when these eyes, we call looking at the numbers that appear here on the top, so every single numbers 1 until 6 come up with a deal we call equal probabilities, which is 1 over 6, 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 1 over 6. Okay, so the probability of x for every single x here, 1, 2, 3 until 6, is all equal to 1 over 6, which is in between 0 and 1. So 1 over 6, every single probabilities here are all in between 0 until 1. And the summation of all the probabilities. Okay, so first is 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6 and another 1 over 6 equal to 6 over 6, or overall equal to 1. Okay, so with these two results, then we come up with a conclusion that x is a discrete random variable. Okay, so now the result of the previous, okay, the result is here with this 1 over 6, 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 and 1 over 6. So the probability of x less than, or less than only, sorry, of x less than 3. Okay, so this is discrete, meaning less than, we call probability of x less than or equal to 3, and probability of x less than 3 are not equal. Okay, so probability of x less than or equal to 3 meaning the summation of the probabilities beginning from 1 here until 2 until 3. But then for this case, it's a summation of probabilities of x from 1 until 2 only. 3 does not include. Okay, so then we're talking about the probability of x. Well, we have here probability of x 1 until 6. So probability of x equal to 1. Probability of x equal to 2, which is 1 over 6 plus 1 over 6 equal to 2 over 6, or simplified as 1 over 3. Okay, and then the probability of x probability of x in between 1 until 3. Okay, greater than 1, less than or equal to 3. Okay, so for this x greater than 1, meaning this does not include with 1. So if not include with 1, so we take this next x value of x here, which is begin from 2. It is equal to x equal to true plus x less than or equal. So then probability of x equal to 3. So then because all probabilities with the equal are equal, which is 1 over 6, so 1 over 6 plus 1 over 6 equal to 2 over 6 or 1 over 3. Okay. Random variable x has the following probability distribution function. Okay, so k is unknown. We got no idea what is the value of k. There is the value. This is value that we need to find first, and then we substitute with the real value of k. Then we solve the question. Then, okay. So the way k is a constant. So if I make this one as a summation of all the probability of x equal to 1. Okay, so then it begins from 1, 2, 3, 4. The rest are zeros. Okay, then so we come up with probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3, 1, 2, 3, plus with probability of x equal to 4. Okay, so then it is kx plus kx plus k5 minus x plus with k times 5 minus x, which is equal to 1 here. Okay, now kx plus kx, 2kx plus with 2k5 minus x, which is equal to 1. Okay, so then I continue above here then. We got 2k and 2k. Okay, so I make adjustment here. So just imagine that k and this k, okay, with the x here is for 1 and 3. The function of kx with x equal to 1 and 3. So when x equal to 1 and x equal to 3, so 1 times k equal to k plus 3k. And the function of k times 5 minus x when x equal to 2 and 4. So just imagine that 5, substitute with x equal to 2 here, 5 minus 2 equal to 3. So 3 times k. And then when x equal to 4, 5 minus 4 equal to 1, 1 times k equal to k. So the total of this, 3 plus 3 equal to 6, plus 1 equal to 7, plus 1 equal to 8k equal to 1. Then k is 1 over 8. Okay. So then, if I write all again, probability of x equal to an x. Okay, so then kx, k5 minus x, and 0 here. For x equal to 1 and 3, x equal to 2 and 4, and otherwise. So we first show that the value of k is 1 over 8 just now. So we rewrite all this. Substitute the value of k, 1 over 8. So it is 1 over 8 times x, and 1 over 8 times 5 minus x, where x equal to 1 and 3, and here is x equal to 2 and 4, and 0 otherwise. Okay, so now we write all this in a table form. Okay, so we show this in a what we call probability distribution table. Okay, So I need to come up with a table here. Okay. X, probability of X equal to an X. Okay. X equal to 1, 2, 3, 4. Okay. So when X equal to 1 and 3, substitute X, 1 and 3 into this function here. 1 times 1 over 8 is 1 over 8. And also 1 over 8. Oh no, this is 3 over 8. 3 times 1 over 8. And then when X equal to 2, 5 minus 2 equal to 3 times 1 over 8, 3 over 8. And 4, when 5 minus 4 equal to 1, 1 times 1 over 8 is 1 over 8. Okay, so then the mode is 2 and 3. Okay, with the highest probability, 2 and 3 here. And then probability of X greater than 2. Okay, as a discrete, X greater than 2, meaning 2, X equal to 2 is not included. Okay, so it is now become probability of X equal to 3 plus probability of X equal to 4. Okay, when X equal to 3, the probability is 3 over 8. And when X equal to 4, and the probability is 1 over 8. So it is 4 over 8, or simplified as a 1 over 2. Okay, so the probability of X equal to 1 or X equal to 4. Union or here, when X equal to 1, the probability is 1 over 8, and when X equal to 4, the probability is 1 over 8. So then 1 over 8 plus 1 over 8 equal to 2 over 8, or simplified as a 1 over 4. Okay, cumulative distribution function. Cumulative come from the root word of accumulate. Accumulate means that we add the value from one probability to another one and to another probability. Okay, so if X is discrete random variable with probability distribution per function of this, then the cumulative is denoted by summation of the probabilities from X1 until X, the numbers that we give them. Okay, next. And we may also find the median. Median means that the middle value of the probability of the table or the data. The probability distribution function of discrete random variable X is given in the table below. So construct the cumulative distribution function, find its median, and sketch the graph. Okay, so just now it is 1 over 8, 3, 3, and 1 over 8. We rewrite 1 over 8, 3 over 8, 3 over 8, and 1 over 8. Okay, so accumulate means that the first probabilities here, which is 1 over 8. Accumulate means that probability of 1, the first one here, 1 over 8, plus with 3 over 8. So 1 plus 3 equal to 4 over 8. And then accumulate until X equal to 3. So the first one, 1 over 8, plus with 3 over 8, plus with another 3 over 8. So 1 plus 3 equal to 4. 4 plus 3 equal to 7 over 8. So then, the last one here, 1 plus 3 equal to 4, plus 3 equal to 7, plus another one is 7 plus 1 equal to 8 over 8. 8 over 8 or equal to 1. Okay. Okay, now the median, okay, F2. F2 means that the probability of x from the beginning here, x equal to 1 until x equal to 2. Okay, plus with x equal to 2, then it is 1 over 8 plus 3 over 8 equal to 4 over 8 or 1 over 2. So then the median, which is x equal to 2 here. Okay, next, the graph. Okay, now look at this graph carefully. Okay, so then when x from 1 until 2, okay, and then accumulate when we call x from 1 to here, and then next is from 2 to 3, and next then here from 3 to 4, and finally an x equal to 1 here. Okay, final one here, x equal to 4. Okay, so this is how we sketch the graph for a cumulative distribution function. Okay, class, how we define this and we compare. Okay, never mind. If I sketch the table of this again from the previous slide. Okay, within x, the probability of x, and also cumulative of x. Okay, when x equal to 1, 2, 3, 4, which is 1 over 8, 3 over 8, 3 over 8, and 1 over 8, 1 over 8, 4 over 8, 7 over 8, and 1 over 8 equal to 8 over 8 equal to 1. Okay, so how we read this graph from this table? Okay, so when x equal to 1, accumulate for fx here, and from 1 until 2, so the value is 1 over 8. So from 1 over 8, from 1 until it reach almost, when x equal to 2. But when x is exactly equal to 2, when it reach up to 4 over 8 here. So this value is 4 over 8 until almost close to the value of 3. So when x accumulate equal to 3 here, then it's come up with a new value of 7 over 8. Okay, and then when x is exactly x equal to 4, then it is value equal to 1. Okay, that's it. So class, for this question, okay, for this table, look at this table here now. Please be careful. Previously, we looked into the table, okay, with the two columns of x and probability of x equal to xi here. Okay, then we come out with a table of cumulative of x. But then look at this one here now. It is between x and cumulative function of x. Cumulative function. There is no column of probability of x equal to an x. So in this case, well, when we talk about this probability of x less than 3, it does not include with 3. But then before 3, we assume that it is x equal to 2. Okay, probability of x equal to 1 plus probability of x equal to 2. Okay. Probability of x equal to 1. Do you find any value of probability of x equal to 1 here? No, because it's only topic of x and the cumulative function of x. There is no probability. Meaning, this is 0.32 equal to 0.2 plus width again. 0.32 minus 0.2 equal to 0.12. 0.2 plus 0.12 equal to 0.32. So this value of x with its cumulative function of fx is already recall in the value of probability of x equal to 1 plus probability of x equal to 2. So we may just strictly take this value of 0.32. Okay, from this table, probability of x equal to 1 is 0.2. And then probability of x equal to 2. There is no value of 0.12 here because this table is with the value of x and the cumulative function of fx. There is no table of probability of x equal to an x. Okay, this one is not in this table here, so we need to come up with these two. Just imagine that it's a 0.2 and 0.12 equal to 0.32 here. Okay, and find the median. Find the median for this one here now. So then, cumulative distribution function of x equal to m here equal to probability of x less than or equal to the middle value, which is m, equal to 0.5. So then 0.5 lies in between 2 and 3 here, in between 0.32 and 0.67 in between here. So we assume that we're taking the m equal to 3. Okay, and then construct the probability. Okay, now from this table we're going to construct the probability distribution table. So look at this carefully. Okay, from here where the x and cumulative distribution function x equal to 1, 2, 3, 4 and 5. Okay, this now cumulative distribution function given here is 0.2, 0.32, 0.67, 0.9 and 1. Okay, so we are going to find this probability of x equal to an x. So first one, of course, it is how we call 0.2. So the accumulate distribution function of fx and x equal to 1 is the probability of x equal to 1 here, 0.2. And what about this probability of x equal to 2? So in this case, probability of x equal to 2 equal to f2 minus f1, which is 0.32 f2 minus f1 minus 0.2 equal to 0.12. 0.12. Okay. 0.32 minus 0.2 equal to 0.12. Then probability of x equal to 3 here. So we're taking that cumulative x until 3, 0.67 minus cumulative until x equal to 2, which is 0.32. Okay, 0.67 minus 0.32 equal to 0.35. 0.35. Okay, and then property of x equal to 4. Property of x equal to 4. So we're taking the cumulative distribution F4, 0.9 minus F4 minus F3 and minus 0.67. Okay. 0.9 minus 0.67 equal to 0.23. 0.23, and then 1 minus 0.9 equal to 0.1. Okay, that's it. It's a property distribution function table here. Okay, random probability variable x has a following property distribution. Find the cumulative distribution function of fx. Okay, if I just sketch it here. Okay, with an x, property of x equal to an x, and cumulative function of x. Cumulative distribution function. There are two values of x here, 1, 2, 3, 4. Negative 1, 0, 1, 2. Okay, so just imagine that if substitute x negative 1 here, negative 1 plus 2 equal to 1. 1 over 10. 1, negative 1, 0, 1, 2. Then when x equal to 0, 0 plus 2 equal to 2. 2 over 10 is 2 over 10 or 1 over 5. Okay. 1 plus 2 equal to 3. They come up with 3 over 10. And when x equal to 2, 2 plus 2 equal to 4. 4 over 10 or 2 over 5. Okay. This is 2 over 10. Okay, now 1 over 10, the cumulative distribution function when x equal to 1 here, the first value is negative 1, 1 over 10, plus with another value of x, 1 over 10 plus 2 over 10, 3 over 10, 3 plus 3 equal to 1 plus 2 equal to 3, 3 plus 3 equal to 6 over 10, 6 plus 4 equal to 10 over 10 or equal to 1. Okay, so now from this table we transfer into what we call in a graph form, in the form of graph, in the form of function, sorry, in the form of function. Okay, this one here, then cumulative distribution function of fx. Okay, x 0, 1 over 10, 3 over 10, 3 over 5, and 1. So what is value here just now? 1 over 10, 3 over 10, 6 over 10. 1 over 10, 3 over 10, 6 over 10, simplified as 3 over 5, and then 1. So then for this one here, which is x less than negative 1, okay, and x less than 0, okay, it is less than negative 1, means out otherwise, okay, beside negative 1, 0, 1, and 2, otherwise the rest of it is 0. Then 1 over 10, 3 over 10. For 1 over 10 here, where x lies in between negative 1 and 0. And this one here, It is x lies in between 0 until 1. Negative 1, 0, 1. Negative 1, 0, 1. Okay. Then x lies in between 1 until 2 here. And then this one is x greater than or equal to 2. Okay. So from this function we call probability distribution function, then find the accumulate distribution. Then here is the one called the function of accumulate distribution function of f, a capital letter of f, x, and then we transform it into the function and we get all this on here. So that's all for today. Thank you very much. I do hope all of you enjoy with this video and you get something. So please do continue with your tutorial and pass your questions. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.